Good evening. I think we can just start because of time. I have managed to share these notes. I think maybe from tomorrow now you will be in a position to be following up. And also yesterday's recording. So yesterday we just did an overview. I was taking you through the curriculum, what to expect, and so on. Today, we want now to start on the theoretical part of the introduction to data science and analytics. And we are going to start by the definition of data science, data analytics. After the definition of data analytics, we are going to highlight the process that you need to follow in data analytics, projects, and so on. After that, we are going to define what data science is. After defining data science, we are now going to compare the differences between data analytics and data science. Then after looking at the differences between data science and data analytics, we are now going to see at what point do they complement each other as we progress on. So to define data analytics, we are saying this is the process of analyzing raw data so that you are able to pull insights which are useful to companies, organizations, and so on. So basically, maybe just to explain those terms so that you understand, when we are talking about any data that's available in the organization that has not been made ready for consumption is raw data. Whether you collect it from the field or you have stored in databases, as long as it is not in a process that can drive any kind of insights, then we are talking about raw data and so on. So again, we extend by saying that data analytics is kind of business intelligence, and later on, we are going to see that business intelligence basically involves analyzing historical data alone and make decisions. So it extends up to business intelligence, or it is a kind of business intelligence that is used to solve problems and challenges that we are facing. So basically that's the definition of data analytics. You are trying just to analyze or manipulate raw data to be able to derive some kind of insights that are used for decision making. So, having seen that, we need to know what are the steps for data analytics. The most important thing before you start any data analytics process, you need to define the question you need to answer. That is, maybe why are you conducting the analysis, and also what kind of data do you need. We understand that in organizations we have a lot of data, right? Not each and every kind of data that you have will be used. So we have only relevant data that will be necessary for specific kind of analysis and so on. So that means maybe the marketing department, for instance, can consume a different type of data as compared to operations department, as compared to the finance department, and so on. So all those departments are able to use different kind of data specific because you need to answer a certain problem. So maybe you want to analyze data that will inform the marketing strategies that you are going to deploy as a company. What it means that maybe you will need data on the products that the customers are consuming, the demographics, and so on. So based on that, maybe you are able to do what's called targeted marketing and so on. After knowing the question you need to answer, now you proceed to data collection. Data collection does not mean specifically that you need to design a questionnaire and go to the field. Data collection means even if the data is available in the organization, how am I going to retrieve it. It does not specifically mean that you go to the field. We are going to look at such a case as we proceed, whereby we find that in one scenario, there is a readily available data that you need to use, and in another case, it means that you are subjected to go to the field to look for the data before you come up with the analysis and insights. Then after that, after data collection, we have what's called data cleaning. Data cleaning is a subset of what's called data pre-processing. Data cleaning is the process of making your data ready for further analysis. And here, mostly you address the issues of missing values in case they are available, consistency, and so on. Because we are going to see what called the data quality assessment matrix. Before, when you receive any kind of data, we have very crucial metrics that you need to check before you proceed with the analysis. Those metrics will assist you in what's called data cleaning and other, of course, data pre-processing methods and so on. After the data cleaning, now you go to the analysis of the data. Analysis of the data, for instance, maybe if the analysis, an example, if you need maybe to know which month of the year do we receive the highest amount of rainfall, what's the average amount of rainfall, which region do we sell more for a specific product, that's now the analysis part of it, whereby you come up with the metrics, specific metrics, or you try to answer the questions that you formulated at the beginning, because when you started the process, you already defined the problem that this is what I need to achieve. So the problem you define now will be, you will be able to solve it in the analysis section. After that, the most important part of all of this is interpretation and sharing of the research, the communication aspect of it. For instance, maybe you are analyzing data, you are trying to see the trends in form of sales in your organization, in form of maybe for weather forecasting, the trends in rainfall received, and maybe you want to advise the farmers and so on. So this is the part you need now to share insights. Why is it that this scenario is happening? Based on the data, this is what we are able to observe. But also, as a data scientist or analyst, you don't need to stick to make your decisions based on data alone also. You need also to have diverse knowledge also, because for interpretation of the results, what it means that, yes, this is what the data is saying, but what's the general business environment and so on. Like, let me give an example. Recently, we have been having tough economic times globally, right? So many companies' revenue have been dropping, but I'm very sure you don't have access to your data for your competitors. That's an internal business. Like each business has their own internal data and so on, which cannot be shared. So you find out that you can analyze data, you see that things are not maybe working properly. You need also to look at why is it happening. So looking at what is happening globally, for instance, we have been having, for instance, the conflict in various countries that has been affecting maybe supply and demand. So you have to have also the general knowledge. You don't just make your interpretation sticking to what you have seen, but when you are explaining the reasons also, you try to cut across to look at what is happening globally and so on. So it means that you need to have diversified kind of knowledge. So basically, these are just the steps that you need to follow when you are handling data analytics project and so on. So we have defined data analytics. We have said is that process of analyzing or manipulating raw data for you to be able to derive insights that are used in decision making. So that's the definition. But let us look now at what is called data science. Then after that, we look at the definition. We are able to look at the differences between the two, and now how do they complement each other. So one thing about data science is that many articles, many people, scholars and so on have been coming with various definitions. It's not like those scientific, we have this scientific naming. It doesn't have like a scientific naming system like we find for diseases. If it is COVID-19, they give a universal name and so on. So many articles and publications use the term data science freely with the assumption that it is universally understood. So that is the assumption that has been there. But when we are defining data science is that it involves methods, goals, and applications that evolve with time and technology. Therefore, it means that data science has been there. For the last 25 years, data science has been there. And during that time, it referred to gathering and cleaning data sets, then applying statistical methods to that data. Especially those people who are doing statistics and so on. Whatever they were doing, still it was part of data science. But now, due to the fourth industrial revolution, whereby everybody almost has access to the internet, access to smartphones, the nature of the data that is being generated or collected currently is diversified. It involves both what we call the structured data and unstructured. Structured data, as I mentioned, like if I have an organized list of the students attending this session in terms of the name, the email address, the phone number, like this class has about 16 students, both virtually and physical. So that list is structured data. But unstructured data, we are talking, for instance, social media posts, which can be in form of images, can be in form of text, can be in form of voice notes, and so on. That is unstructured data. And also nowadays, for instance, businesses, many businesses have social media accounts. Maybe daily, the marketing department, they are trying to post some content and so on. So you are able also to analyze that text data to know among your posts, maybe which one, like in terms of the reactions of the followers of your page, maybe how many people were neutral about this post, how many were positive, and how many negative comments you had. Then after that, you are able to make a decision. The same to the Google reviews. You are able to analyze it using what's called the natural language processing, and you are able to get those insights that can assist the marketing department to make better decisions. Another thing interesting, maybe before I proceed further, because when you have access to the Google Cloud, you are able, if I want to compare, for instance, I want to know among the banks in Kenya, which one is the best one. I just build a machine learning model that is able to mine all Google reviews data for all those financial institutions. Then I compare the rating based on what customers are saying. Then I'm able to make a decision, because that is publicly available data that you can access as long as you have the Google Cloud account and so on. So as we are saying that now in 2018 onwards, data science has grown to a field that is made up of data analysis, predictive analytics. Predictive analytics, basically, you are trying to look at the future. Data mining, here you are trying to understand the patterns in data. Business intelligence, you are trying to use to historical data to explain what had happened. Machine learning, here you build algorithms or models that are able to maybe predict maybe certain disease prevalence, in finance, maybe fraudulent transactions, and so on. Deep learning, um, deep learning is part of artificial intelligence, an introduction to artificial intelligence, whereby you are able to build models that are more uh, powerful or robust and are able maybe to extract, to do like image analysis and so on. So in short or in summary, what it means that data science is a discipline that is made up of diverse subsets or sub-disciplines. So it involves business intelligence, machine learning, deep learning, and so on. That's why as I was taking you through the curriculum yesterday for certified data scientists, you saw that all those sub-disciplines form what you call data science. So we have seen the difference between the two, data science and analysis. So we have seen that data analysis is part of, also is a subset in data science. But having seen that, maybe to enhance further understanding, let me take you through the next slide. I want us to look at the difference, the key differences between data science and data analytics by looking at three focus areas. The first one, we are going to look at the objective and focus of each one of them. The second one, we are going to look at the methods and approaches each one of them uses. And the third, we are going to look at the skill set and expertise that you need in data science and data analytics. So let us start on the objective and focus for data analytics, then data science. In terms of objective and focus, data analytics focuses on understanding past and present data patterns to optimize business operation, enhance efficiency, and gain a competitive edge. Or, in summary, what that one means is that data analytics is more focused on immediate decision making. For instance, if I want to know how many students have attended, how many male students have attended maybe today's physical class, maybe I'm talking of 3, right? That is immediate. I'm able to get immediate response, maybe 3 out of a total of maybe 7 students and so on. But it does not tell us why that is happening, right? To tell us why that is happening, maybe why do we have that trend, it means now data science algorithms are able to answer that question. So looking at the objective and focus for data science aims to uncover hidden patterns, relationships, and trends to solve intricate problems, and of course making predictions or recommendations based on data-driven insights. What it means is that data science is more exploratory, like it tries to uncover the hidden patterns, to go deeper, to find why a specific scenario is happening and so on. So that's the difference between data science and data analytics when we are looking at the objective and focus. In terms of methods and approaches, data analytics mostly follows a very streamlined process. And this process mostly, it focuses on what we call descriptive and diagnostic analysis. Like it is trying to descriptive, like to get a summary of why something is happening and so on. And it involves data cleaning, which we have seen. Visualization. Visualization is part of just communication. Statistical analysis, for instance, if I want maybe to forecast what will happen in the future when I have some historical data, that's part of statistical analysis. Data mining techniques, trying to understand patterns, and also it does this using tools like Microsoft Excel, structured query language, and data visualization tools or software such as Microsoft Power BI or Tableau. But now data science, you see, it involves a holistic process or a broader process, if I can say, and it includes data acquisition. Acquisition of data is part of data collection and so on. Cleaning of data, of course, both we have cleaning of data. Exploration of data, to explore my data, maybe I want to know, maybe in this class, I want to know maybe what is the age distribution of the male students to female. So that means that I'm trying to explore my data. After that, after exploring your data, you now want to transform. For instance, if I want to use those information or that information to make a decision, and I find out that the age distribution of those, the male to female students is not normally distributed, like it does not follow, like there is what's called some kind of imbalanced data set. Imbalanced data set is whereby you find that maybe 30% of people are below this age, then 70% are in another age category. You see that difference is so big, it is called an unbalanced data set. So that process of making it balanced is part of what's called transformation. So after I transform now, I go to modeling. Maybe I want to build a machine learning or a model that is able to predict maybe the performance of students based on age and gender and so on. So that now it is called modeling. Then after I build my model, there's what's called evaluation. Evaluation now, you are trying to see how is it work, what's the percentage of accuracy. If I bring in new data to this model, or if I deploy it for production in the industry, is it able to give maybe a performance of 80% and above, and so on. So that is part of what's called evaluation. And therefore, one thing about data science is that it deals with both structured and unstructured data with complex. Of course, unstructured data is very complex. How to analyze images, text, and so on. It is a bit complex. And this one now, it needs some kind of sophisticated algorithms, such as artificial neural networks and deep learning and so on. So we see that with that now, data science involves, like, is a very wide process, like it covers many areas and aspects and so on. In terms of skill set and expertise, data analysts mostly, as you say, that focuses on data manipulation, right? Data manipulation, visualization, and storytelling. And therefore, to achieve that, you need structured query language. If you are working, you want to retrieve data directly from the server. Mostly it's used for data querying. You need manipulation skills, data manipulation skills, and you need to visualize for the purpose of communication and so on. But when you go to data science, apart from the data analysis skills that you need programming languages such as Python or R, algorithms, and big data frameworks such as Hadoop, because nowadays Excel has improved a bit, I see, It can nowadays analyze text data, the Excel. If you have the modern version of Excel, it can analyze text data. Like if you have customer um, queries and so on, it is able to analyze. But when it comes to like images, to analyze images, voice notes, and so on, it does not have that capacity. So therefore, you need these tools. That's why we say that data science has been there. What has changed is the technology. That is what has changed. That's why now it means that you need more sophisticated tools to be able to manipulate. So maybe before I give you room to ask questions, I want to take you through two more slides. Then now you can ask any question. So there's an example here. Just leave alone the data engineer. We will come, or we will be able to cover on data engineering. There's this company called Wonder Waters. It has departments on water filtration, the water products. What it does, it has water filtration function, water distribution function. Of course, we have other byproducts maybe that they are making out of water and so on. We have two colleagues here, Liz. Liz is a data analyst, then Tom is a data scientist. So what Liz does as a data analyst in this company under water filtration, the first thing, she is able to analyze water quality in terms of looking at the pH value and level and so on. Then after that, she recommends new water products also based on data. Then after...
Sorry, this one is very cute.
Okay. Let me check on that. Yeah, I see. Yes, I need to check on my... What about now? Am I audible?
Somehow, yeah.
Okay, sorry for that. So I was just giving an example of what Liz does. Okay, thank you, Mike. So Liz does the analysis of water quality in terms of pH levels, seeing the pH level. Then she recommends new water products. Then after that also, she identifies current demand of water products. And the last function that she does is that she enables business to build market strategy, because based on that historical data and so on, what Liz does, when you identify current demand of water products and so on, it is easy now to enable businesses to build market strategy, because if you know that maybe these specific products sell better than this one, or these products can sell better if they are bundled with other products and so on, you are able to come up with a very good marketing strategy to optimize on sales and so on. Then Tom works under the water distribution as a data scientist. What Tom does is that Tom builds statistical models to predict potential health benefits of consuming Wonder Waters, packaged drinking water and so on. So Tom focuses on the modeling part of it, predicting the potential health benefits of consuming Wonder Waters, packaged drinking water. So you can see how the data analysts and data scientists work in companies that employ these different people to perform different roles. But in most cases, other companies, they can just employ Tom to do, first of all, what Liz does before he comes and it comes to do what a data scientist does. So having given this example, let us first of all look at now, how can we bridge the gap? That means that the collaboration between data science and data analytics. So we have seen that from the previous slide. Let me check if there is a question. Yes, Selam.
Yes, sir. So you talked about Tom, and you said that Tom is responsible for building the statistical model. So do you have an example of how a statistical model looks like?
Okay. I think it is premature to demonstrate the theoretical class, but mostly just to give an example, let me give an example. There is a model called linear regression. For instance, linear regression, the way it works, it is trying to compare two variables, what you call the independent variable and the dependent variable. Dependent variable, if you are dependent on something, it means that maybe an increase in one thing can lead to a decrease or an increase on the other, right? But independent, it means that when you are independent, irrespective of what happens, it means your status quo will remain the same, right? So an example of a model is like the linear regression model, whereby maybe an increase in the cost of sales, an increase in the cost of production materials will lead to automatic increase in the prices of commodities. So that's a sample of a model um, that I can give. So an increase in one thing will lead to an increase. So that one for instance linear regression, but on models you will learn practical a lot of models, especially in machine learning. The whole of machine learning is modeling up to the end. But I hope, Selam, that example has assisted you to understand an example of a model.
Yes, sir. Thank you.
Okay, thank you. So let us look at where data scientists and data analysts collaborate and so on. So it is clear that we have said that while data science and data analytics have distinct characteristics, they are not mutually exclusive. What it means that one, there's some kind of dependence or what it means that they complement each other, right? So, so what it means that they complement each other mostly in providing a comprehensive and a holistic approach to data-driven problem solving. So what it means is that data analytics forms the foundation for data science. And it does this by providing insights that guide the process of data exploration. I have given examples, several examples of data exploration, data modeling, and of course, prediction. Therefore, we say that data science leverages advanced algorithms to build what we call predictive and prescriptive models using the insights generated by data analytics team. So it depends with the organization, as I say. Some organizations, one organization that I know, for instance, in Kenya, um, one organization that I know, for instance, in Kenya that has various roles in data science and business intelligence department is Safaricom. They have a data analyst, business intelligence analyst. They have data scientist, machine learning engineer. Like, they have divided those roles. But in most cases, you find out that in some organizations, just a data analyst, as a data scientist, you must know the part of data analytics before you go to the data science part of it. So, having discussed up to there, before we proceed and look at what's data and so on, I would like to, maybe in case any concept is not clear or you have any questions, I'd like to hear from you. Both the online, the virtual team, and the team that is here physically. Any questions? Anything that is not clear? Is there clarity now between data science and data analytics?
I have a question.
Yes.
You've seen that there's a data engineer, you have a data analyst, and a data scientist. Is it possible for one to be all of them, or it's recommended that one specializes with one of them?
Okay, the best is to be all of them. As a data scientist, you can do all those, because with SQL you can do data engineering. SQL and big data gives you capacity to do data engineering. The main reason you see, this is a young profession still, especially in Africa, and most organizations still, in fact, there's a lot of confusion that I normally see. For instance, there's this role, let me divert a bit. There's this role called business intelligence analyst and business analyst. Most organizations do confuse between the two roles, but we will be coming there. But with respect to this, I'll advise that it is better you know an end-to-end process as a data scientist, so that if you go to an organization that do not have capacity to hire specific people that specialize in specific domain, you can still handle the projects end to end without a lot of frustrations and so on. So it is an advantage if you are able to play all those roles, because data engineering basically is that process of preparing data, raw data, for further analysis. So you need to know how to do so before you proceed with the analysis and so on. Yes.
The data engineer has already processed the data. He has to give it to the data analyst or the data scientist first.
Okay, so the data engineer, after preparing the data, if we get organizations that has divided those roles, after preparing the data, you can pass to the data analyst. As you have seen, that the data analysts, they form the foundation. So what they do, the analysts will provide the insights that guide the process of data exploration and so on. Now, after the data analyst looks at it, now they pass to the data scientist, who is able just to build the models and proceed from there. If we find organizations that have those specific people and so on, that's how they can collaborate. Let me check the online questions. I'm seeing some notifications. Yeah, Mike, I see your hand is up.
So my question was, you have well explained concerning the bridge between data analytics and data science. Meaning most of the concepts which data analysis is learning is the same concepts that someone who's doing data science with that's comprehend. Maybe is there any bridge? Is there any difference in now in the statistical part? Maybe learning that's learning statistics. Is there any, or will we learn generally all of us both the analytics and the science?
Okay, thank you so much. Yeah, the statistic unit will learn both the analyst and the scientist because you see, to do data exploration, as you have seen that data exploration, as I have explained, maybe you are trying to look at how your data is distributed. You will be plotting some plots. We have what called the box and whisker plot. You will be explained how it works. That one, for instance, when you plot, it will show you if your data has outliers or not. You will learn maybe one thing about the skewness and so on, like how your data is distributed. And if you find maybe the mean is greater than the median and so on, it means your data is, this is how it is distributed and so on. So both, you need that knowledge to assist you in what you call data exploration. You need that statistical knowledge to do data exploration and of course modeling and prediction, because in statistics also we will introduce you to linear regression and linear, which again you will meet in machine learning for those proceeding with data science and so on. You'll find the approach is a bit different, but the concepts are the same on the basis. So both you need the statistics concept is very crucial in data science, especially on doing data exploration. I talked about the issue of the imbalanced and imbalanced data set. You know, maybe why should we use a bar plot in this kind of data? Why do we need a histogram? Why do we need a pie chart? Why do we need a line chart? There's another thing we call the Pareto that we are going to learn in we have some kind of a graph that maybe on one side you have the numbers, on the other side you have the percentage and so on. All that you need to understand why you should use that and when dealing with which type of data and so on. So Nixon, I hope your question is answered.
Yes, and also one last question. Maybe we have other platforms for analytics, like for instance MATLAB and maybe R. I don't know whether it's of benefit to have this knowledge. Maybe to have knowledge in MATLAB, since you'll be doing by for those who are doing data science.
Okay, thank you. If you look at these notes at the end of it, you can see we have all those. I'm going to take you through each end of them, but mostly MATLAB is used in academia, especially those people maybe doing masters and PhD, and when you want to do mathematical modeling, because it gives you the capacity to write maybe those formulas, if you want to derive the formulas and so on. That's the purpose specifically that MATLAB was used. When we come to R, I don't know if I explained in this class. In fact, myself, I'm an expert in R as compared to Python because that is what I used for a long period of time before I moved to Python. Because R became a bit outdated, and when they tried to, what R happened, in R, they have what called R Studio. In the year 2022, September there, they changed the name to POSIT. And the main reason why they changed the name to POSIT, they were trying to copy the interface of Python because Python is very simple and so on. And in that process, there were a lot of bugs and so on because they were also trying to improve. So, but if maybe I want to build a predictive model using regression, using Python or R, still you will end up in the same result as long as you are using the same data set. So the only difference is that the learning curve for R is really quite steep. For instance, in Python, I can just write one line of instructions and I'm able to get whatever I want, while the same in R you write up to 5 and so on. So that's the only difference between the two. But in terms of whatever you want to achieve using either R or Python, still will be the same as long as you are using the same data set. Mike, is that okay? But also, maybe let me explain one thing. R, you see, R when it was initially built, it was built as a statistical package before now. It was improved to handle data science tasks. Basically, because R initially it was just built to do what SPSS, that is statistical package for social sciences, and Stata could do. Then after that now, as it kept on evolving, they were able to add what called the data science libraries. A library, as I said, is a collection of tools that are used for specific purpose. For instance, also it can do data visualization and so on. The same can be achieved, but the initial idea of building R was to be used for statistical analysis and so on, especially those on the research side. Yeah. So Mike, is that clear before I look at other questions?
Yes, it's clear. Thank you.
Okay. Let me check questions here first. Okay, I think Mike, I have answered your question that you achieved the same.
Yes, yes.
Okay, any other questions maybe from the team here? Any question? In case you don't have a question, maybe for the sake of our brother who has just come in, I can give a quick recap, but I'm recording. So basically what we have done so far, we have introduced what data analytics is, and what we have looked into, we have said is the process of just analyzing raw data to be able to answer some specific questions or problems. And we say that when we are talking about raw data, we are talking about data that is not ready for decision making, so there's need for transformation. After that, another thing we have defined is the definition of data science. We have said that data science has been there. What has changed is the technology. And therefore, data science is made up of diverse subsets, like data analytics is part of data science, business intelligence, machine learning, artificial intelligence, deep learning, and so on. They are part of data science. Also, we have looked at the differences between the two and how they complement each other. And what has come clearly is that the foundation of data science is data analytics. It means that you cannot be a data scientist if you don't know data analytics. So that is briefly what we have been able to cover so far. I think in case we don't have questions, we can just proceed from there. I also shared the materials by email. You can check later. So I want us to look at data, what data is, because the foundation of data science is data, right? And I want us to look at data by looking at the traditional data and the modern data, or what you call big data, right? So let us look at what we call the traditional data. As we have said that data is the foundation of data science, and therefore data is the material which all the analysis are based. And in the context of data science, there are two types of data. That's the traditional data and what we call big data. And when we are talking about the traditional data, let us not view it based on maybe age. Maybe you are talking about data that was collected 5 years ago and so on. No, that's not traditional data. Basically, when you are talking about traditional data, it's data that is structured and stored in databases, which can be managed from one computer, and mostly it is in a table format containing numeric or text values. So this is an example of a database that you can see there. Because a database is just a computer that has been built specifically to store data with maybe SQL server installed into it and so on. And in most organizations, I hope you understand that we do have the data room, the control rooms and so on. If you enter there, you'll find some kind of images, whatever you can see here. So, but let me explain better. I understand that maybe you might have handled various kinds of data in your organization that is in an Excel format and so on. That is basically traditional data. So even the list of students I'm training, it is traditional data because it is organized and is in table format. But when you are being admitted, we do collect, I think there's where you are being told to upload an image of your passport size photo and so on. That now becomes, if I combine your name, phone number, and the image, it becomes what you call semi-structured data. Then of course we are going to look at the unstructured data, but what you should know about the traditional data is any data that is structured and is in table format, and mostly it involves numeric values or text values. For instance, if I have your name and your years, or your name and phone number, your name will be a text, right? Your phone number is numeric, and so on. So that is an example of traditional data. So we now have what we call big data, or big data is what we call the modern kind of data and so on. So when we are talking about big data, we are talking about this is extremely large data, and this data is distributed across a network of computers, but it is not just characterized by the volume part of it. The data can be in various formats. It can be semi-structured, it can be structured, semi-structured, or unstructured. So let me give an example. The mobile network operators like Safaricom, Telcom, Airtel, MTN, and so on, they have millions of customers. Millions of customers. Even so, you see that amount of data, it might be structured but very voluminous. Excel, for instance, I think it cannot handle data with more than 1,000,000 rows. Of course, nowadays there's what called BigQuery. I don't know if you have ever heard. It is able now, you are able to manipulate even such huge data sets in Excel if you use the BigQuery and so on. So, if you have data that is in table format, that is voluminous and cannot be handled by ordinary tools like Excel and so on, then that can be classified as big data. Then we have the semi-structured. There I have explained, maybe I have your name, phone number, then your image, a combination of text, numerics, and images that we can call semi-structured. But now unstructured data mostly is what people post on social media, like Facebook, Instagram, TikTok, X, and so on. That is unstructured data. Mostly the images text and all that. It is part of the unstructured data. But we have other characteristics of big data, or what you call the the non-traditional data. One is variety. Variety, what it means that it can be in form of numbers, text, images, audio, mobile data, etc. This means that the formats can vary. Another one, velocity. Velocity mostly is related to speed. This big data is retrieved and computed in real time. For instance, if I'm your friend maybe on social media or Facebook or Instagram and so on, when you post something even right now and I'm online, I'm able to get it in real time. Whatever you have posted, maybe you have updated your status in the last 1 minute and so on. So that's how big data is transmitted. Then it is voluminous. Like uh, an example, even as we are speaking or seated here, how many people are posting on social media? There's a lot of content that is being shared in social media and so on. So those are the main characteristics of the non-traditional data and so on. Maybe before we proceed further on what do you do to data and so on, we have a question on the difference between the traditional data and big data.
So maybe the traditional data is purely like the text and numbers, no images, no nothing.
Yes, yes, yeah.
And the rest is big data.
Yes, the rest is big data. But also we have said that traditional data that cannot be analyzed by an ordinary data analysis tool such as Microsoft Excel forms big data because it is so voluminous. Even if you open your laptop sometimes, even if it is very powerful, you find it is hanging and so on. That one forms part of big data. However, they have not given like what do you call, like a universal benchmark at what point that says that at what point are we going to classify this as structured big data or not, because on the other aspect, when you are talking about images, voice notes, text and so on, that is very clear and straightforward. But mostly you will find out that big data solutions of problems or data, mostly we handle it using big data tools such as we have what called Apache, Spark, and so on. Mostly they are integrated with Python, and they use also SQL queries and so on. So that is mostly how big data is handled, and you'll be able to see how I understand it is the last unit in the curriculum. Maybe before I proceed, you still have a question? Okay. Mike is asking that is it right to call traditional data manageable data? Like any data can be easily managed, but I think maybe I can take the second part of your question that it is simply short and able to be manipulated by very simple statistical tools like division, mean, and so on. So this mean, division, and so on are the statistical. These are some kind of metrics and so on. So yes, it is can easily be manipulated, but it doesn't mean that traditional data is easily manageable. No, that is not the case, and so on. Selam, you have a question?
Yes, sir. I heard you saying that audio, texts, images, and numbers are forms of unstructured data. Yet previously you've just said that text and numerical values data can be introduced in a form of a table, and that's what we call traditional data. So I got confused when you said that there are forms of unstructured data.
Okay. Thank you for the question. Basically, what I said is that when you have both unstructured, I can say unstructured and structured data combined, it forms semi-structured. Like semi-structured, it means I can have, I was giving an example, your name, your mobile, maybe your mobile number, phone number, and then your image, that becomes semi-structured. Yes, it doesn't mean that unstructured data is totally different. You cannot put it in general in maybe a table format. Sorry, I lost my internet. Just a minute, I connect.
So I couldn't hear you.
Yeah, I lost my internet. Sorry for that. Okay, whatever I said is that we have what called the semi-structured data. Of course, it is very rare, but I say that semi-structured data, mostly you find that there's a combination of maybe images and text and what else? The numeric part of it, like it is combined together. Yes, it can still be stored in a table format, but if you find unstructured data alone, for instance, whereby the images, we have images, text, and so on, in most cases, if it is purely unstructured, they are not stored in table format. But maybe to make a clarification, if it is semi-structured or structured, it can be stored in table format and so on. I don't know if that clarification is okay.
Yes, but what I was trying to ask is, are are all numerical values or text values considered to be unstructured data?
At all?
Because yeah, I'm saying you've just said that images and audio form, text or data are considered as unstructured data, right?
Yes.
So what about the text and the numerical values? Are they all considered to be unstructured or they're considered to be unstructured?
So I have said if the text and numericals is combined maybe with the images, then we can call it semi-structured. But if we have text and numerical alone, then that is structured kind of data. I don't know if that is now clear.
Okay, there, yeah.
Okay, thank you. Yes, Mike? Yeah?
Okay, thank you for that clarification. Meaning the traditional data only carries the structured table data, but the big data carries the three, both the structured, the semi-structured, and the unstructured.
Yes, yes, exactly. Because I have given an example. If I have, for instance, a list of students, I have 1,000,000 plus students, your phone number, your maybe your country of origin, and your name and so on, and it is more than maybe 1,000,000 rows in Excel, or I can't analyze it in simple tools and so on, then that one, yes, the data is structured, right? But it is big, like the volume, it cannot be analyzed by using ordinary tools. Maybe I might need to analyze it using tools such as big data frameworks such as Hadoop and Apache Spark and so on. Uh, Basically, those are the tools that can handle big data and so on. So that is true, Mike. Okay. Any other questions? Let us ask questions in case. have them.
So anytime you're trying to categorize your data, you have to, like, you can use the characteristics of the big data, the velocity, volume, and just the other thing. So you check if this data is like more than the terabytes or this type, like this unstructured or structured. Like you can categorize it using those three.
Like these characteristics or
Yeah, like
this
you
one.
can use these characteristics
Yeah.
to see if your data is unstructured, structured, or semi-structured.
Yeah, but mostly this one will fall under big data. Like it is only the two main characteristics that you can use to understand structured semi and structured semi. It is structured, semi-structured, and structured because the ones that you have given velocity, still you can use it to know. Yeah,
What kind of data you're handling.
exactly. Still you can use it to know it is true. You can use the characteristics of big data to try to assist you to filter out, to understand the kind of data that you are handling, and so on. Yes, any other questions? Yes.
Still on structured and unstructured data.
Yes.
What differentiates? What makes the difference? Is it how it is stored, or what type of data that is in? Because maybe like SQL data is stored in tables.
Yes.
Then there are other technologies that uses NoSQL.
Yes, exactly.
Is it the mode of storage that differentiates, or what the data is?
We have the mode of storage first, the speed of transmission, and also the what the data is. Those are the three main things you look at: how it is stored, how it is transmitted, and the structure of the data. You look at all those three metrics.
Is it okay to say that SQL cannot handle unstructured data?
Yeah, mostly it cannot. Uh, Unstructured data mostly is handled by, it is called Postgres. It uses almost the same querying language. It's like just an extension of SQL. And also, when you go to the big data frameworks, you learn Apache Spark and Hadoop. It uses the Postgres language to be able to retrieve that kind of data. But if you will find out that it is almost, it borrows heavily from SQL. Yeah. Are you satisfied with the response? I'm saying not yet. Okay, maybe with time, as we progress, it becomes a bit clear, especially on the practical aspect, when we are done with the theory. Maybe let me check other questions here. Yes, Mike?
My question was on velocity. I would just request for an explanation of this. It's retrieved and computed in real time. Does it mean that, can you say that, okay, just expound on it. Does it mean information that is able to be collected, but that's computable also? That's any method that we know. Is that what velocity can you respond on that?
Okay, it is retrieved and computed in real time. So basically what it means is, as I said, like when you post an image, maybe on social media now, right? Facebook is able to update it in real time. Like as compared to other data, for instance, when the data comes maybe to the database, maybe you need to do further analysis or manipulations before further consumption. I don't know if you understand the difference just from the practical life experience. If I post something currently, when maybe I post the video in TikTok, it will just be processed in real time, and you are able to, the other people are able to see. But when you are dealing, especially maybe the data um, that passes through the traditional methods and so on, before you use it, maybe to make decisions and do so, yes, you have received in the server, but it might need so much of further analysis before you can use in maybe making decisions. You cannot retrieve it in real time and so on. So that's the difference between the two. Like the velocity, the transmission speed is very high and so on. I don't know if that is clear, Mike.
Yes, it's clear. Thank you.
Okay. Any other question?
I have the same question that Mike has asked.
Yes, yes.
Maybe if you post something on social media and it appears immediately,
Yes.
I don't know if that can, I don't understand that, because if Facebook would have chosen to analyze whatever image or data you posted,
Yeah.
they would have done it, right?
Yes, yes, yes.
But
So,
I'm trying to imagine a scenario like a supermarket.
yeah.
People are buying and then they are scanning products,
Yes, yes.
and then maybe someone in the back office can immediately see the patterns of what people are buying.
Yes.
Is that what maybe that velocity might mean?
Yeah, even in the back office, let me give you an example. I think I mentioned yesterday briefly. For instance, I have the SQL server, right? I connect my Python to the SQL server, so I build an analysis model in Python. Then again, I connect the Python with the Power BI or Tableau for those people who want to see the dashboards. So what normally happens when that data hits the SQL server, it is being transmitted to maybe my analytics engine in Python. Then from the Python, then again, it is being consumed by Power BI for people to be able to see the dashboard. So the only difference between this is that sometimes in traditional data, the transmission speed is not as fast as the systems in the big data aspect and so on. That's the difference. It does not mean that the people in the back end are not able to see and so on, but it can experience some kind of delays which are very rare when it comes to big data in terms of transmission, the speed at which the data is being transmitted. That's the only difference. Yeah. Let me check if we have any other kind of question, then we can consider look at something else. Okay. And we can look at something else so that maybe by 7:15 we are able to close. But in case you are tired, as I said, you can just walk out. We have water somewhere there. You can take some water so that I know that you have come maybe from work and people are always tired, especially if you have a busy day. But let us look at something small on what do you do to data. And I'm going to give two scenarios that I'm looking for to your responses to assist me to understand the two scenarios. So imagine the following scenario. You are an analyst for a large company and your manager approaches you with the following request. One is that we need to consider client satisfaction in the next quarter. So we can predict churn rate. Churn rate, maybe for those who don't know, is that using an example, if you have been subscribing to Netflix, right, maybe on a month-to-month basis, and you stop using it, then it means you have churn. So if we take the number of people who have stopped using Netflix divided by the total maybe base that was there or using for that particular period of time, then you get the churn rate and so on. So I've been told that we need to consider the client satisfaction in the next quarter so that you can predict churn rate. Then you have been told to oversee the process and come up with some numbers. That's the first scenario. The second one, you have been told we have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver approximation of churn rates for the next quarter? We have these two scenarios. I want you to assist me to understand the two scenarios. What difference can you see from the first scenario and the second one? What comes out? Maybe let me repeat and read once more. We need to consider client satisfaction in the next quarter so we can predict churn rate. You have been told to oversee the process and come up with some numbers. The second scenario is that we have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver an approximation of churn rates for the next quarter? There's something that is very clear there, but let me start from the team that is online. Yes, Selam. Can.
So, according to my observation, in the first scenario, we're considering, we're looking at only one customer. We're trying to find the details of the customer service of one specific client or individual, whereas for the second scenario, we're looking at a number of customers.
Okay, thank you so much, Selam, for the attempt. Maybe Mike, you can also have your perspective.
So the first question, the first statement is a predictive statement, and there is no fact that's been failed whereby the analyst can back his predictions from. But the second statement, the analyst has been given the liberties to amass information from previous quarters and maybe get from the information from the previous information, then they can make predictions from now unavailable data. So for the first statement, data is information given. For the second one, there is information, chunk of information.
Okay, thank you, Mike, for the trial. We can have as many views, the team here. Yes.
I think in the first scenario, the manager is asking if the data analyst can use maybe live data in the current processes and come up with maybe trends or whatever, or the target using the data that is maybe real time. And in the second statement, he is asking the data analyst to use data that is already available from the last quarter to analyze and see some trends.
Yeah, sure. Thank you so much. I want to see various perspectives. Any other person who has seen something maybe different?
Okay, for the first statement,
Yeah.
the manager is requesting if the data analyst or whatever can use the client satisfaction data to predict the churn rate of that specific quarter, like so that they can oversee the future maybe numbers of how the churn rate churn rate for the next or for the future? Like,
Okay, thank you. The final one maybe from the team. I want to give the team here. Then one online, then we will be able to discuss further. Any attempt? Yes.
According to Neil,
Yes.
what scenario the analyst is going to perform predictive analysis. But now for the first one, the churn rate is going to be dependent on the outcome of the client satisfaction. And then the second one, they already have data from the previous quarter that they will use for the analysis for the next quarter.
Okay. Thank you so much. Let me just see the another hand that is up here. Then we will be able to. Yes, Kevin.
From the we see that the first case is a data science problem whereby the analyst has to come up with a model or a statistical model that can predict, for example, that can predict if a certain movie, for example, in Netflix, can have a certain number of, for example, satisfaction number, for example, 4 or 5, 6, something of the sort. The second case is the data analysis problem, whereby the analyst has to come up with visualization and also present a report what was this thing, something like that. I think that's what I feel.
Okay, thank you so much, Kevin and everyone. Yeah, I understand that already people have gotten what I wanted, but maybe before I can mention what is the difference between the two scenarios, there's a common thing that your manager wants to be solved in both scenarios. What is it? Churn rate, yes? So in both cases, the common business problem here is how we are going to solve the churn rate. In the first scenario, you don't have ready data. But in the second scenario, you already have data in your organization that you are going to use. So it means that in the first scenario, maybe you might be subjected to go and maybe administer a questionnaire to be able to collect data that you are going to use and so on. So the difference was that one you have data, the other one you don't have ready data. And therefore, that one will take us to what we call the raw data and what we need to do into it. But I don't want to introduce that concept now. So tomorrow, I will introduce the concept of data in processing. Given that we have understood that we have this kind of data, what do you need to do to the data before maybe further analysis? At the same time now, that's where we are going to introduce the roles of three people. First, we are going to introduce the role of a data architect. We are going to introduce the role of a data engineer. And we are going to introduce the role of a database administrator. So we are going to pick from there tomorrow. I'm going to share the link, the link for today's recording, still by email and WhatsApp group. So be checking them when you have your own time. The notes, the entire notes I have shared, unless in case you don't get, just let me know. Yeah, so I think I did not see you yesterday. Were you there yesterday? Okay. Maybe you can just introduce yourself by name. On my side, I'm called Xavier Aluku. And in the notes, I already indicated my name. Maybe you are also willing to know maybe you by name and maybe the profession if you are comfortable with that.
My name is Igal. transition to networks. Now I want to transition to data science.
Okay, nice to meet you, Egan. It's good we have just started today. Yesterday we were just doing the general overview of the curriculum and so on. I have shared the same via email, and I hope, yeah, I saw your name, so if you check your email, you'll get it. But in case of anything, let me know. Yeah. So thank you all. Let us meet tomorrow, same time. Have a good evening.